Today, I'm going to discuss with you Praval Deep Research, which is an AI-powered assistant for those that are reading technical papers of different kinds. These could be academic papers, they could be technical reports, PDFs from archive, what have you. So, really, Praval Deep Research is meant to solve the problem of the discoverability of insights from technical papers, and it provides sophisticated tools with AI agents working in the background, doing some of the hard work for you so that you don't have to do all the heavy lifting with respect to basic tasks that you have to do as a researcher, maintain a knowledge base, summarize your papers in a fast fashion so that you can determine if it deserves your attention. And as part of your knowledge base, add and remove papers from there, build concept graphs that could be used to link different kinds of ideas together, and chat with your papers and see if that can help you understand the papers better. So there's all these different features and many more that we're going to explore today on Praval Deep Research. First and foremost, I'll spend a couple of minutes discussing Praval. Praval is an agentic AI framework. I've developed this over the last 8 months or so, and it's currently a sub 1.0 release, but it's a pretty mature framework that I've been using for a number of different applications. Praval Deep Research is one of those applications that I have spent a lot of time on just to ensure that I can solve a problem that I have on a daily basis. As an ML engineer, as a leader in the ML space that is leading a team and that wants to give the best possible advice on the latest technology that's out there in AI, I spend a lot of time keeping up with technical papers. And I think that there's a lot that happens in just a week, and in some cases, in just a day. There's multiple breakthrough announcements that change the landscape. So my own problem was that how do I really determine if something is worth my time? And how do I determine if a paper is worth exploring further? If I can find other papers that are related to it, if I can find and discover papers that use the same terminology, or if I have already read something that is similar and if it's in my knowledge base, can I use a second read of that paper really to get deeper into that subject? So all of these are top of mind considerations for me as I was trying to build Praval Deep Research. Now, the application window that you see here is really divided into three key areas, and one of them is the discover feature, the other is a chat feature, and then there's a knowledge base feature. And each of these it has its own dedicated set of tools and sub tools and things that you can use, and we'll get into all of that. So the workflow here is really discovery, analysis, or exploration of the topics in a paper, and then the creation of a knowledge graph or a summary or those kinds of terminal workflows that you might have as a researcher. So discovery is the first step of this. And as you can see here, when you click on the discover research papers piece, you can see that in my case, I've already got a knowledge base with a number of papers and it has provided a summary here. This summary is automatically generated. You don't have to do anything, and you just have to keep searching for and indexing papers. And I'll show you how to do that. Once you do that, there's an agent that's running in the background that parses the content of your paper and picks up what the research areas are and puts them out here as research insights. You also get suggestions here in terms of there might be some underexplored ideas, there may be ideas that you've not touched despite having touched related ideas. And this is a way for you to populate your search window with those topics and then get to those. So in addition to, so there's externally facing searches, which are currently centered on archive, but potentially we could expand this application to target other kinds of paper repositories as well. And archive, as you all know, is a preprint server, so it focuses on papers that have not necessarily been accepted into peer-reviewed journals. Although I think archive in many cases is a pretty credible source of papers, especially if they come from good research labs. Moving on, there's also an internally facing search. And here I've used Vajra Search, which is a framework that I have built, which is, to my mind, the fastest BM25 and semantic search that's in existence in the Python landscape right now. It scales very well. It is comparable to ZVec, which is a library that Alibaba released a few months ago in terms of performance. Again, I've been building this since last November, and this can do a range of things, starting from semantic search purely on the one hand, which is just conceptual similarity using vectors, all the way to keyword search, where the exact terms that you're entering into the search field are matched in your papers, and then those papers are returned. And this basically searches the knowledge base as opposed to searching any external server such as archive. So there's a distinction in that sense. Moving on, we have the chat feature, and maybe we can take a quick look at how the discover feature might work. I'm going to just see if I can search for attention mechanism, which is a very popular paradigm in machine learning that's been used in large language models and the like. So if I run a search for this, it should hit the archive server and it should pick up a number of papers that are from archive. All right, so it did come back with the result, and as you can see, it took a bit longer than I have seen it take. Normally, it should be pretty fast. Let me try another search. I'm going to try FaceNet, which is a contrastive loss related paper, and you can see that the FaceNet paper really comes up pretty fast, and a bunch of other related papers come up pretty fast. I'll try another one on random forests, right? So you can see that there's a number of papers that have come up here. I'm going to just select one of these, and it seems an interesting paper. I should probably check these out. And as you can see, as soon as I selected the papers out here, those boxes got checked, and then I got this option to index those papers. So if I index these papers, they get added to the database. And this is a desktop class application that I have here, Praval Deep Research. So there is a local repository that it will store these papers into in your home directory. And not only does it store the actual PDF paper, but it also stores the vectors that it has constructed using the content of the paper and then the embedding model that it uses behind the scenes, right? So it's indexing those papers and it has just completed that. So if I were to go into my knowledge base and search for random forests again, I'm likely to find those two papers in there. And you can see that each of them come with a BM25 score. And that's because I'm doing exact keyword match searching here. If I were to do semantic plus balanced keyword match, I might get, of course, I get the same two results, but then you can see that that capability exists. I could search for other topics in this fashion. And there are a few seminal papers in here. This one in particular is very popular, as you can see. Language models being few short learners. Anyhow, I hope that gives you an idea of how the discovery of research papers, both in archive and on your knowledge base, works. I'm just now going to move on to the chat feature, but there's a cool trick that I want to show you. I want to choose this paper and I'm going to say chat with one. And essentially, what I've done is to open up a chat window inside the same Praval Deep Research application, where I can ask questions about this particular paper, for example. And what it does is it uses the content of the paper and prepares a response for me. So I asked it what a few shot learner is, and it responds saying that a few shot learner is a model that can perform a task with only forward passes at test time, typically with a few dozen examples in the few shot setting. So as you can see, this is a very specific response. And this is not a general LLM response that you might get where it might just describe few shot learning based on some general knowledge that it has accumulated through pre-training. What it does here is, since there's an agent that has the specific context of your paper, that actually picks up the question and then responds to it in a very specific way. So this direct answer is backed up by evidence from the papers that I've indexed. And there's some technical details and some limitations that are also bubbled up here. So the end state for any of this kind of interaction is really to share what we have found or to prepare something that we have learned here as a resource that we can look back on and document. So there's an option here to do that. You can create a blog post You can create an academic style blog post with a table of contents. And if you were to click on that, it would construct a blog post based on the answers that you, based on the conversation that you had here. And you can see that it created a rudimentary blog post for you in Markdown style. And of course, this is illustrative and you can really take this much further. There's also the fact that this is open source, so you can go in and tweak the prompt and you can build a version of this for yourself that really generates the kind of result that you want. This is on the chat piece, and as you can imagine, there's all of the typical chat functions that are supported here. And if I were to just open up a chat and then so you can see here, I've created a conversation around a meta harness and I've not given any context here. As you can see, this is just a fresh chat that I have created by just clicking this new chat button. But then what it has done is it has gone in and studied my knowledge base and it has picked out multiple papers that are all related to this topic. And it has used those as references to answer the question. So this is, yeah, still retrieval augmented generation, but it does perform the research and provide you citations and so on, right? So as you can see, you can explore a topic in a fair amount of detail thanks to this kind of interface, right? So let me move on to the next topic, and that is the knowledge base. So the knowledge base is where you'll see all of your papers that you have indexed visible to you. You can see the all of the details here in terms of the title of the paper, the authors, how many chunks there are, and this is just indicative of how many chunks of the paper have been used to create embeddings of, and then embeddings of the paper, and then those embeddings are then stored in memory for retrieval tasks and for things like question answering, right? You can view the PDF of each paper, and in case you have got your paper from a source that is not archive, you'll see this grayed out here. But then if you have got it from archive, you'll see the archive references. But so you can actually open the archive page directly from the app, which is, I'm sure, helpful. An interesting feature here is that you can find all the related papers. You can extract citations from any given paper, and then the associated papers that are there in the citations are shown to you. And then there may be situations where you have already indexed some of those related papers, and those are highlighted as in KB, which means in knowledge base. And there may be some other papers that you might want to index going straight from here, or maybe you want to check out the archive page first before you do that. So there's options to do that. You can select and you can index directly from here as well. So this is a nice way for you to look at your knowledge base and then identify papers of interest and then identify related papers to those and then expand your set of papers that you have on your knowledge base, right? So this is supremely useful for those who want to be in a flare out or an exploratory mode. And I find that a very useful feature. Now, there's ways to import papers into the knowledge base that you can handle right here from this interface. So on the files and folders section, you can just drag and drop PDFs directly into this, and they may not reference that they're from any given website like archive, but the files will be indexable and queryable within Praval Deep Research. So you can add PDF files, you can add specific folders, you can add specific paths. You can also go into the text and markdown links section and you can paste a number of archive links, and each of those will get checked in a pre-flight check kind of a process, and then you will be allowed to ingest them into your knowledge base. So there's some nice features here for importing papers or reporting technical reports. Another use case that I can think of here is, let's say you work in a large organization, you have a number of different kinds of reports that you've prepared for different experiments that you've done or for different scenarios that you run in some process. Or maybe you have a lot of different kinds of reports that you want to explore and understand and read in detail or maybe dig into in the chat and stuff. So you can use Praval Deep Research for those kinds of situations as well. It doesn't have to be for academic papers. Even though the primary hook here is to archive, you can literally use this for any other use case. Moving on, there's a nice feature that I'm building, but it's not perfected yet. And this is the concept graph. The concept graph is essentially a set of nodes and edges that illustrate how different concepts in your knowledge base are connected to one another. And it also illustrates how individual papers may be linked with each other. So you can see here that there's a paper scaling law for quantization aware training. And so that's this paper out here. And you can see that has several concepts that are present in the paper. If you were to choose a different paper, and all the papers here, just for reference, are in blue. Earlier in the video, we saw neural random forests, and you can see that there's a number of concepts that have been picked up from there. We had just indexed this paper a minute ago, and what you can see here is that paper has been understood by the agent that deals with the creation of this concept graph. All the concepts from it have been extracted and they've been put into this form so that they can be used. We also saw that at the same time we indexed this neural random forests paper, we also indexed a denoising random forests paper, and that's also present in the knowledge base, although it appears to not have been converted into concepts yet. But you get the idea. And in truth, I'm trying to improve the parsing of concepts from these papers so that you can get a more useful, higher level, higher quality kind of knowledge graph. But that's still a work in progress. You can do subgraphs here that I think is a nice feature. You can do so many hops from any given particular paper. And the benefit of this is if you have one hop or two hops, you can really explore in a more deliberate fashion the nature of the connections between these concepts. And that's currently at the paper level, but equally we could tweak this around so that we can make this a bit more flexible and we can go by concepts instead. So these are the 3 or 4 key features of this Praval Deep Research application. There's a settings field here. There's a settings page here where you can choose the kind of LLM provider that you want to use for this. Being a desktop application, this is currently using OpenAI keys, but then equally you could run Olama on your system and then connect it to whichever Olama model that you have. So you can have a completely local solution with the exception of the outgoing archive API call. And even if you don't want to use the archive API call and you just want to load up your own knowledge base, you have a fully local application that way. So you can see that you can manage your keys here, and then there's a couple of other configurations here, one for embeddings and one for structured extraction of PDFs. And for that, I'm using Gemini. You can switch between dark and light modes. So this is what light mode looks like. And of course, the bulk of the video has been in dark mode. And you can reindex the entire knowledge base as well. Let's say that you switched from the text embedding 3 small to the text embedding 3 large on OpenAI. You can reindex your knowledge base so that you can get better retrieval, better responses. In a nutshell, that's what Praval Deep Research is all about. It's an exciting application for those who want to manage their academic papers and their knowledge base in one place. And it provides you agentic querying of papers. It provides you agentic knowledge graph creation and sophisticated ways to manage your knowledge base and figure out interesting things that you can do with the papers that you read, whether it's posting content about it or exploring ideas related to other papers that are connected to this one. So there's a lot that you can do with this. Try this tool out and see if it excites you. If you have suggestions or ideas, get in touch with me. I'm AI Explorations on Twitter or X. And I'm also available on LinkedIn. I'm also at aiexplorations.in. That's my website. Thank you.